Well, hello friends. Today we are going to make SDL play sound on Serenity. So I recently got a Nintendo emulator running here, so we can now play Nintendo games. But how fun is it really without the sound, right? I feel like we really need to have that that music playing, you know, like especially when you go and you collect some power up or something, you really want to hear that cool sound. So that's what we're going to do today, because the emulator Nesalizer, it's built on top of SDL, and currently we just disabled the audio in Nesalizer in our port, but we'll start by not doing that. So the way that we disable it, we have this no sound patch which we apply. And it just does an early return whenever we're going to do audio processing. And then it also just neglects to set up SDL audio. So first thing we'll do is we'll just remove that patch. No sound. And then we're going to have to make SDL know how to play sound through our sound system. So that's not something that I really know how to do, but we'll figure it out. So we have our SDL port here. This is the Serenity SDL port. Where do we see that? Here. It's our own little branch of it. It has a bunch of fixes and stuff. So I assume that we can look in the CMake lists for some sound thing. Some different sound APIs that we can have supported. Maybe there's audio. Okay, so these are the sound systems that SDL has right now. Now, which one would be closest to our API? So we have the audio server in Serenity, which is just like a local socket server that wants shared memory buffers with 16-bit 2-channel 44.1 kilohertz samples. So let's look at this one. DSP sounds promising because I would love to have something just really simple. A raw mixing buffer. OSS. So this, I guess this might be for the old sound system on Linux. I mean, it doesn't stand for old sound system. I think it's open sound system. This is what we were using on Linux before we had also. So how does this work? Detect devices, close device, open device. What do we do here? OpenDevice. And we get some spec. So I think we can force down the audio spec to whatever we want, because we want it to be 2-channel, so we can just say, screw you, even if you try to ask for 4 channels, we'll just force you down to 2 channels. That's good. And open the audio device. So this just opens a file descriptor, I guess, for like dev DSP or whatever it was called with OSS. And then we want blocking I/O. Really? Okay, blocking I/O. And then what does that mean to use blocking I/O for the sound? Does that mean that you keep you block until you played all the samples, maybe? That's what it means in Serenity. We'll see how that works out. And then get hardware formats. I guess then, like, trying to figure out which SDL format for the sound to use, and based on what's available according to the device. Blah blah blah. setting the audio format. So here they set some format that they agreed on. Number of channels, frequency, and then this, I guess this fills in whatever you didn't fill into the spec is filled in here. Fragment size, I don't know what that is. Maybe that's some OSS specific thing, or maybe how much you buffer at a time or something. And then just allocate a buffer. So that part seems pretty straightforward, actually. Should be able to map that to audio server stuff. And then when you want to play, then we just send the stuff like this. Okay, we just write it to the file descriptor, it's fine. And then get device bus. This one doesn't seem like a port specific capture. We can't record sound, so this will just be a dummy. Same thing with this, no capture. Init, just setting up function pointers, I guess. And oh, that's the end of it. Oh, and then I guess we fill in one of these to say how to find us. Well, we can totally do this. So let's just do this. And then how do we make it build this? Serenity. So now let's do, I don't know what these things are, but I'm just gonna add them. Audio, SDL, audio driver Serenity. We'll do the same thing here as well. I'm no wizard at CMake, so maybe I'm doing something stupid here, but okay, and we'll also need lib audio. Okay, and let's see if we can build this CMake. Serenity is definitely enabled. Wait, I feel like nothing happened there. Okay, let's take a look at this. Oh, you gotta rename these. I guess we'll call them like this. No, wait, what am I doing? MB. Okay, now we are building. Then we have to do something actually interesting in these. So first thing, I guess, is just changing these type of things. This is not going to swing with C++, so we'll change it to that. So we're converting something from C to C++, but they're using this as a variable name. Yeah. So we'll just make sure we got everything. Okay, and then DSP, we'll just change that to Serenity Audio. Okay, and then here is this little, I don't know, this little descriptor, I guess. So Serenity, audio server sound. Okay. And then we had capture stuff. We should probably just do nothing. Just do I don't know, EIO, whatever. Okay, does it still build? Yes, it does. Oh, and we have this thing right here. So I guess we should say Serenity. Wait, does this actually get built? No. Why doesn't this get built? Wait, where does this come from? SDL config. Video driver Serenity. Oh. Audio driver. Because these are in alphabetical order, so we'll just stick to that. Okay. Now, can we please? Oh, it's a big change. Okay, well then we can look around a bit. So, in this file right here, it should fail to build when we get here. Then, the really interesting part is this part right here, where we open the device. And then open device and then play device. Those are the important ones to implement. So let's see. We should definitely get rid of these because we're not on Linux. So then I guess we'll include libaudio. A client connection. Okay, yeah, that didn't work out. On DSP audio as well, right? A client connection.h. Well, what's it called then? It's called a client connection. Maybe we don't install that. I've never used libaudio outside of Serenity itself, so there's no install script here whatsoever. So let's install this stuff. Audio. Okay. Now we also need this. So okay. A client connection. Right. So same thing with the audio server. All right. So now we got lots of build trouble, but we can deal with this. I think, or wait, where the hell does this trouble even start? Fffff. Okay, so we're off to a bad start there already. Okay. So now we have to clean up OpenDevice. Maybe we'll make this a little bit bigger. I'm just going to do this in Vim because I don't want to import SDL into QCreator. But maybe I should, actually, now that I say it. Import existing project. Yeah, let's just do it. Okay, and then Serenity audio config. Audio driver Serenity is 1. Okay. And okay, there we go. Now we gotta get rid of all these IO cuddles, because yeah, let's not use Vim. It was a bad idea. So when we open the device, then yeah, we really don't care about the device name because we're going to make a connection to a socket. So what we want to do is say that. Let's make sure that we have a storage for this. Connection. All right. Does anybody include this except us? Probably not. So we can also just say client connection. Yeah, that's probably fine. Okay. Wait, now what's this? It's that. Okay. Wait, how do we get to the private thing then? Is that hidden? Okay. New client connection. Let's see how this is used elsewhere. Like this. Okay. And we do a handshake. All right. So then connection should really be a ref footer, actually. Or let's just include it like this, a client connection. Okay, seems fine to be using C++-y things. So we'll do this, we're still good. That hidden connection handshake. Okay, so now we should have a connection to the audio server. We don't need to care about the device name anymore. And I don't know what this handle is about. And then here we're just going to force down the spec to a specific frequency. Channels to spec. Oh frick, what are the formats even? Do they have? I think these are open sound system formats. But not exactly sure. SDL audio spec. Format is format values. So I think we are using signed 16-bit, so it'll be that one. Probably specifically in little endian byte order since we're on Intel, but I'm just going to say shit, I already forgot where they were going. Audio S16 LSB. That'll be us. Okay, spec. Samples. Audio buffer size and sample frames. Total sample size by channel count. Wait, where did that comment come from? Oh, that's so neat. Huh. I never saw QCreator doing this. Like how it's describing the data structure here. It's so cool. I'm gonna need something like that for Hack Studio, when we get to that point. So the samples count, let's say, I don't know, 500 samples. Might be a little too little, we'll find out. So then we can just delete this stuff. Oh, and here we allocate hidden, so it doesn't exist yet. So we should probably chill out a little bit on using it. Okay, there we go. Okay, this is where we open the audio device, which is what we were doing here. So now we don't need to do this anymore. Boom. That means that dev name is no longer used. If that hidden is null. Yeah. Blocking IO. Well, we don't have the audio file descriptor anymore, so we should get rid of that. That'll tell us what stuff here is not useful. Then it's just asking the system for formats. We only care about one format anyway at the moment, which simplifies things greatly. Setting the format on the device, setting the channels, setting the DSP frequency. We've already done all this up above here. I suppose we could do it further down though. Okay. And then I think this fragment size is not something that we need to care about. And then this is a bunch of things that we also don't need. And I wonder what this does. Calculate audio spec. Can we jump to it somehow? SDL audio. Calculate the silence and the size of the spec. Wait, what? Oh, so it's determining like what's the data to fill with to create silence. Byte from memset. Okay. Oh, that's kind of interesting. That it's not exactly silent if you're using unsigned 16 bits. Because they memset with it, and they want hex 8000, but because they memset, they get hex 8080, which is a little bit off. Strange. Okay, so then basically this just sets the silence byte and the size value based on format, channels, and samples. And we set all those format, channels, and samples. So I think we should be good with that. Then we want to play something. Then, wait, why does this look so freaking goofy? Look at this, so weird. Probably redo this in a more C++-y way, but it's not the most important thing. So H connection. Now we're going to want to enqueue a buffer here. So we need to make an A buffer. And we have H mixbuff and mixlen. That's the raw data that we have. Oh, this is a bit tricky. So let's see, what do we do with this? We need a buffer, that's for sure. Create. We need samples. So we have to turn this stuff into samples. What do they normally do? Direct sound. What do they do here? Look. Play device. Oh, this is so hard to read. Swizzle funk, blah blah blah. PCM right. Okay. So this kicks us in the butt a little bit here because our audio server see, when we get in QBuffer, then we are expecting to get an buffer object, which has inside of it samples, which are a sample objects, which have a left and a right float value. So that's not going to be what SDL is producing. So we're going to have to transform the SDL mix buffer into this. Alternatively, we could do that on the server side. We could make it so that you can open up like a PCM channel to the audio server, and then you can just stream PCM data, and then audio server will take care of it on his side. That's probably what we should do in the long run, but I think now we're just gonna set this up on the client side and do conversion here. So it's the easiest way to create a buffer like this. Oh wait, hold on, from PCM data. Oh, maybe we can use this. Ooh, let's see. This is used by the WAV file loader. Raw samples. Give it a resampler. Okay, let's try this. Interesting. So, raw samples is going to be a byte buffer wrapping around the H mixbuff, H mixlen. Okay, and if there's nothing in it, then we'll return. And then non-channels is 2 bits per sample. I guess it's 16. And then we need a resampler, whatever that is. Let's get rid of this. M resampler. Okay, so we make one of these. Sample. Wait, hold on. The sample rate is always 44.1. Oh, but like here, if we wanted to set it up so that you can use arbitrary sample rate in SDL, then we could do that. But right now, this is just going to be a dummy resampler, I guess. And then we do that. Ooh, I wonder if this would just work. That would be fascinating. libc, oh, we can't do that. Okay, a buffer. libc. Okay, why are you so mad? Why do you have to be mad? IO-cuddle. We still have IO-cuddle somewhere, maybe? No? Okay, so what do we do here? That hidden connection. Hidden connection is null there. Okay. AFMT. What? SDL audio. Wait, what are we doing wrong here? I don't get it. Maybe I have to say extern C. Jesus. SDL audio format. Where's that coming from? Okay, why did stuff get weird all of a sudden? Oh shit. I bet that it reorganized the includes. They were probably in order for some reason. Oh, I hate this type of crap. Alright, let's see. Let's see what it was like originally. DSP audio. What am I doing wrong? Okay, audio format does not name a type. Let's just so we're including this and expects audio format. Okay, and where is this defined then? SDL audio.h. So we need audio.h before audio c.h. Okay, that was it. Frick. Alright. Install, and then let's go here and bravely build the NES emulator. And sync and run. Let's see. I feel like this is not going to work, but right. So what did we get here? No available audio device. I bet you that SDL has no idea how to find us. So how does it find the other ones? DSP. It's looking for this thing, right? The bootstrap. So I guess here, these two. Yeah, we want to put ourselves here. So strap and SDL audio.c. We'll just put ourselves at the end here. Okay. Ah, alright, here. And now the port. Okay, that's progress. We're failing to link. Let's see. Probably gonna have to do something more here in the port. File. Where do we link against stuff? Here. Just slap on the audio as well. And G++, G5, and this one is missing. Okay. enum Unix. It's all grayed out. Maybe we can just do SDL audio driver Serenity. I don't know if we actually need this stuff, but we can probably leave it in. Let's see, make clean and make test dir clean source run root install. Oh, wait, that didn't work. Maybe I need C compiler as well. Yes, okay. Initializer right here. Audio buffer overflow. Okay, so we are glitching and I'm not hearing anything. Also, that picture is too big. Let's I know there's a scale factor here, we can just tweak that. All right, and then let's see, audio buffer overflow. I bet you that if we had a higher sample count, it would be less of a problem. Let's just go with 1,000. I wonder if we're actually queuing up those things though. Maybe we should log that we're doing this. Queued and queuing some samples. It would be so cool to get sound working in SDL, because then we will be able to play more games, all the Nintendo games, and we could even play Quake with sound, probably. Okay, I heard a click and then we died. And queuing some samples, so it's definitely happening. In queue samples, I guess in queue fails, or how does that work again? Calling in queue on the client connection. Oh, it will loop until it is able to enqueue. Sleep 1 second in between. But it wanted non-blocking I/O, right? Well, I'm not even really sure. But why is it failing though? Assertion failed. RC greater than 0. 79. So we are selecting while waiting for a specific message to get back to us. We assert that we should have gotten a P error right above. Well, I guess RC could be 0. Debug printf, select, turned. I don't know. I'm not really sure what this condition is, but let's have a look at it. Because we're selecting on this one file descriptor a connection to the server. And I guess this could mean that it's disconnected us, which we would then fail because of. Because then we get EOF, basically. Well, although even if we would get an EOF, then it should become readable. So select should succeed, and then a read should give us a 0 length buffer. We'll see. Okay, so things get very dead here. We assert that RC is greater than 0. iServer connection line 79. Oh shit! I have to rebuild Nasalizer. Okay. Maybe that audio buffer size is still way too small. Fine, let's do 4,000. I don't care. Or maybe I do care a little bit, but 2,000 then. I wonder how big it needs to be. Maybe that 1 second delay in Q is going to really hurt, really not work either. That's not really how that should work, actually. What the frick is happening here? It disconnects the thing when it dies, and then we crash in the kernel. That's not very good. So select return 0. I wonder why. On is server connection. From PCM data. Wonder how many samples we're doing here. A buffer is sample count, right? Something here is not going right. What's happening in NQ? Let's do a much shorter sleep here. Just see how that works out. My poor computer. Okay. Well, that died very quickly. 2,000 samples. Wait, now it just fails immediately? So I guess we're just queuing these up, and then what are we expecting to happen though? Like SDL play device. Oh shit, what was it called? So how does it work? It's callback based, right? So you get a callback. Spec callback. So we call the callback when the device needs more data. You can use QAudio instead, but I guess probably most code uses callbacks. But then what happens in the server side? And Q buffer. If Q is full, can we control our queue size? We can't really control the queue size, but what if we decided that the queue size can only be 1? Then we wouldn't allow you to have more than 1 sample buffer queued up. I wonder if that would make any difference. It just dies. Okay. I mean, it dies because of this, but why is this happening? Why is select returning 0? Let's have a look at select. I wonder if there's an error now. Well, it wouldn't return 0 if there was an error now. So it returns the number of marked file descriptors. And if we time out, what if we time out? Does that thing have a timeout? There's no timeout passed, so this thing should run forever. but it doesn't. Okay, let's look in this thing. So if we get a -1 and it's an E-inter, then we just try again. It is not -1, so we return 0. What am I not seeing here? There are multiple threads. I suppose that might be an issue. What if another thread is messing with us somehow? Closing the file descriptor or something? That would be really jerkish, but would they really do that? Let's turn on debug IO, I guess, see what happens. Okay, this is very wordy. Don't really see what thread we're in. Close. Let's see. If current, or if name and says we should log current thread. Okay. I just want to see what it looks like. Both thread 0 and thread 1 are selecting. Should be fine. But, oh, hold on. Client connection. Oh, shit. Wait, maybe this is expecting to run on the main thread. Oh. iServer connection. If you're running this on a second thread, then this notifier, it's going to call us back on the wrong thread. That won't be very good. Shit. Okay, so I don't want to start breaking this up right now. So we're going to pivot in a different direction because this is a bigger architectural problem that we can't make an IPC connection if you're not on the main thread, because then things get really screwy because we don't handle that well. So we're just going to backtrack a little bit. And instead of using audio server, we are just going to send the PCM directly to the sound card driver. And then it won't be perfect because it won't be able to simultaneously play sound with other and get mixed together by audio server, but we should still be able to play sound. So we'll backtrack, put the file descriptor back, and I think we can still get rid of all these things, but here we'll just say audio, FD is OpenDev oh, write only. And then instead of doing the resampling, we can just write to audio file descriptor, mixbuff, and mixlen. And we don't need these guys. I wonder if this would just work. That would be kind of funny. I guess here we should hit that hidden audio FD. It's not -1. Close that hidden audio FD. Okay. Yeah. Wait, how do we fail here if it doesn't work out? If hold on, we'll do it this way. Oopsie doopsie doopsie, what the heck am I doing? Okay, why can't I keyboard today? There we go. Unable to open dev audio. Okay. Install, and then we'll rebuild Nasalizer. And I almost feel like this should just work. Because now we're just going to take the PCM directly into the thing. Oh, wait, hold on, what's this? Sound Blaster driver is complaining that the length is, it asserts that the length is less than the page size. I guess we're sending too much at one time. So let's go back to 100 then. I'm sorry, maybe that is too big. I think the Sound Blaster driver chokes on, yeah, it chokes on less than or more than 4 kilobytes, which it's definitely not perfect, but it's just implementation detail. Could do a lot of work to improve the sound drivers. Oh shit, dude. It's the sound. Huh. Can you hear that? Alright, that's pretty neat, man. Okay, we gotta go pick up the morph ball so we can hear the sound. Okay, that's so cool, dude. And it really is such a CPU hog, by the way. I need to investigate that separately, but it should definitely be possible to run ancient Nintendo games without churning the CPU like this. This is close, just chilling out here a little bit. Okay, so I think we made a lot of changes here that we don't need. Servers, live audio. Don't need this change either. These changes are probably good. installing libaudio. Install lib and headers. Why am I abbreviating like that? Same for audio server. Git commit audio server. Install headers. But can we do something fun? Let's try this on the Quake port. I'll have to do a rebuild. Maybe we should allow a few more samples in. Maybe we can get away with 1500. I don't really know how this is counted. I feel like there was a little bit of chokeage there at some points. And sync and run. I'm not sure if I can actually. Oh, wait, that was too big again. Okay, fine. I'm sorry. I guess 1000 is what we're going to get away with. Need to do some work on the sound drivers. Should probably try to do an Intel sound driver instead of this, because right now we're using Sound Blaster 16, which is, you know, simple but ancient. Oh, dude. It works. That's pretty cool. It's not perfect, but it works. Quite nice. So let's see what we have then. Because then we ended up not using the audio library for now. But it's still okay. It's just we should come back in the future and do audio server support when we have the ability to do an IPC connection to the audio server on a secondary thread, because that's going to take too long to make that work now. So that's why I don't want to go into that, because we already spent a bunch of time here. And let's see what we have. Blah, 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 build system, blah, blah, blah. Here, register the bootstrap thingy. And then, I'm not sure we actually needed this. Maybe we can get away without that. Audio dev. Because this Unix thing, detect devices. I think maybe we don't need that. Let's try to build without it. Yeah. Okay. Cool. That seems to work fine. So we'll just add those bits as well. That simplifies our diff a little bit, I think, because then we don't touch audiodev.c. This blob here feels somewhat inaccurate, but who cares? And it really is a mess. Maybe we can have it be less of a mess. Let's see. Let's just I don't want to mess with their copyright headers, so we'll just leave those alone. But we can certainly be a little bit more tasteful here. So let's say -1, filter, 0, fudge ticks. Who knows what that is supposed to be? Do we actually use those in our thing? No, we don't, so we can get rid of that. And this looks weird. This doesn't look right. This is not the audio server sound anymore. It says Serenity Dev Audio sound. Using Dev Audio. Okay, we're just gonna fix this up a tiny little bit here. It looks so hideous, and it doesn't have to, right? Oh, why does this look so weird? Micromanaging. Don't need IO control for control. Signal. But maybe that's good enough. Or maybe I should have kept for control, actually. Okay. That looks weird. Okay. La la la. Look at this becoming slightly more readable. Okay, that's as much as we're gonna care. Git commit. Audio. Add an audio backend. Add a Serenity OS audio backend using Dev Audio. Ideally, we would be using the audio server, but when trying to implement this, I ran into trouble with SDL program clients trying to connect to the audio server from a secondary thread. This is currently not well handled by a client connection implementation in load audio. The audio backend forces the audio spec to use 44100 16-bit to channel samples, since that's how the Serenity Dev Audio is. So that's what the Serenity Dev Audio is expecting. Yeah. Okay, I think we can push that. And maybe we'll do a final full test. And sync. Oh wait, hold on. Make install. Yeah. Okay. Yeah. It's good. There's a little bit of overflow that happens, but I think we're gonna have to take care of that in the Sound Blaster driver, or in some new driver that we write, because the fact that we can't buffer more than 1,000 samples, it's a limitation that we shouldn't be having, I think. But also, probably actually, if we can get the CPU usage down of the emulator, then I would think this would be less of an issue. So, but that's a concern for another time. I'm just going to shoot this guy when he comes here. Aha. Okay, so pretty awesome progress. Now we have sound in SDL programs. And who knows where we'll go next. So I think this is going to be the end of the video. So if you made it this far, then I thank you for watching and for hanging out while we do this. And I hope you saw something interesting. And yeah, I'll see you next time.